Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about analysis of common loops. So let's get started. In previous videos we have learned about how to analyze an algorithm. We analyze algorithm to find out which algorithm is best or efficient. In order to find which algorithm is best, we usually do asymptotic analysis. In asymptotic analysis, we find out order of growth of function to solve a problem. Order of growth of function simply tells how much time your algorithm takes to solve a specific problem. And we have also studied best, worst and average case of order of growth of an algorithm. Then we have studied asymptotic notations. Asymptotic notations help us to represent order of growth of function in one line. And we have studied three asymptotic notations: big O notation, omega notation and theta notations. Now in this video we are going to study about order of growth of a common loops. Why we need to know about order of growth of a loops? Because loops are the fundamental components of a programming language. We use loops a lot. We use loops when we need to repeat something. We use loops when we need to traverse a linear data structure like arrays, stacks, queues. We also use loops to traverse non-linear data structures like trees. And other than that, we use loops to solve many coding problems. So while loop is a very important and fundamental component, so it is crucial to understand loops and to study about the order of growth of a loop. Alright, so let's start with our first example. So this is our first example. In this example, what we are doing, we are running a loop from I equal to 0 till I less than 100. It means we are running loop from 0 to 99, and in each iteration we are increasing I by 1, and inside this loop we are just doing some constant work. It means theta 1 work. If you look at this loop, the input to this loop is 100, and 100 is a constant value. Why 100 is a constant value? Because it does not depend upon the input of an algorithm. So here we do not have any input, so that's why 100 is a constant value. And even we consider all the numbers as a constant because it does not depend upon any input. So can you please tell me the order of growth of this loop? Pause this video and think about it. As this for loop does not depend upon the input, the order of growth of this for loop is going to be constant. And how we are going to represent the order of growth of constant in terms of asymptotic notations? We use notations here, and for constant we use theta because it is the exact order of growth. It means we are going to run this loop exactly from 0 to 99. So far so clear. So let's move on to our next example. So I have added a little bit more complexity to this for loop. So now in this example our for loop is running from 0 to n. We initialize a variable I equal to 0, and each iteration we are going to increase I by c, and we are running this loop till I less than n, and inside this loop we are doing some constant operation. It means theta 1 operation. Now here this loop depends upon the input from the user. So n is going to be the input and it's coming from user. So user can enter 100, user can enter 1000, user can enter 1 million, user can enter 1 crore. So it depends. And here in this loop c is going to be some business constants. So the value of c could be anything, 1, 2, 3, anything else. Anything. So what is the order of growth of this for loop? So let's put some arbitrary value and dry run this for loop to get some idea. So let's take if n equal to 10 and c equal to 2, how many times this loop is going to work? For I equal to 0, it's going to work. Then we increment I by c, so 0 plus 2 equal to 2, it's going to run. Now next iteration we increment I by 2 again, so 2 becomes 4 and 4 is also less than 10, so it's going to run, and so on and so forth. So this loop is going to run till I equal to 8. And as soon as I becomes 10, the loop stops working, because so when I becomes 10, we are checking if I is less than n. So 10 less than n is false. So at this point the execution stops. Okay, let's see this example. If our n equal to 2 and c equal to 6, then this loop is going to start with the I equal to 0, then it's going to add 6 in each iteration. It becomes 6, it becomes 12, and it becomes 12, and finally it becomes 20, and the execution stops because 20 is less than 20 and this condition is false. So how many times this loop is running? 1, 2, 3, 4 times. And how many times this loop is running? 1, 2, 3, 4, 5. So we can say that this loop is running n by c times, ceiling of n by c times, because if you divide n by c, it means if you divide 10 by 2, you get 5, and if you divide 20 by 6, you get some value in points, and we get the upper value. That's why the order of growth of this loop is going to be n by c times. So how we represent order of growth in asymptotic notation? We use theta notation for the exact bound. So here also we use theta notation, and we generally not interested in constant and lower order term. So we cancel out the c, so it becomes theta of n. So the order of growth of this for loop is going to be theta of n. So far so clear. Okay. So this problem is easy. We can easily get the order of growth by dividing n by 2. Okay. But there are some problems where it would be very difficult to get the order of growth by simply dividing the n by c. So we use mathematical method to get the order of growth. How? See, we are running this loop from 0 to n, and in each iteration we are adding c to it. So we can write like this. So we are adding c in each iteration, and we starting from z, and we starting from 0. So we can write it as 0 into 1c, it becomes 0. Then we are adding c in each iteration, so it becomes 0 plus c is equal to 1c, and in third iteration we are adding c again, so it becomes c plus c 2c, and in fourth iteration it becomes 2c plus c 3c, and so on and so forth. And we are running this loop k times, so it means we are running this loop from 0 to k minus 1. 0 to k minus 1 is going to be k. So this is our termination condition, right? See, here you can see that when I becomes less than n, we terminate this loop, or our execution stop here. So this last term is going to be less than n. So we can write k minus 1 c less than n, and after solving this we get k equal to n. We are cancelling out this 1 and c because we are not interested in lower order term. So we can say that the order of growth of this for loop is going to be theta of n. Okay, let's move on to next example. So in this example, we are running loop from n to 0. This time we are running a loop in reverse order. It means from n to 0, and in each iteration we are decreasing n by 1. In each iteration we are decreasing I by c. In previous example we were increasing I by c, and in this example we are reducing I by c, and we are doing some constant operation in this loop. Our n is going to be a user input. It means n is going to be anything like 100, 1000, 10,000, 1 lakh, 1 crore. C is going to be some business constant. Now if I say what is the order of growth of this function, by just looking at this for loop we can guess the order of growth of this for loop is also going to be somewhere n. Okay, so let's use some arbitrary value and dry run this for loop and see. So let's say if n equal to 10 and c equal to 2, we start our loop from n and reducing the n by 2 in each iteration. So at first iteration our I becomes 10, in second I becomes 8, then 6, then 4 and 2, and then ultimately becomes 0. When I becomes 0 we stops. So when I become 0 our loop execution stops, because at this point this condition is going to be false, because we are running loop for I greater than 0, and now our I itself becomes 0, so we stop here. Okay, so how many times this loop is going to run? 1, 2, 3, 4, 5. So if we divide n by c, we can say that this loop is going to run 10 by 2 times. It means n by c times. So let's see with another example. Let's see with other values. let's say if n equal to 20 and c equal to 6, so the I becomes 20 in first iteration, then it becomes 14, then 18, then 2, and then minus 4. So at this point our loop is going to stop because we are only running till I greater than 0 and this is a less than 0 value. So how many times this loop is running? 1, 2, 3, 4. So when you divide 20 by 6, you get 6 3 is 18, 3 point something. So we can say that this loop runs ceiling of n by c times. And in terms of asymptotic notation, we can represent this order of growth as theta of n. And this example also we can prove it mathematically, that we are starting with the n and each time we are reducing n by c. So at first iteration it becomes n by 0c, that is going to be n minus c is going to be n only. Next time in next iteration we are going to be n minus 1c, n minus 2c, and so on. And the last iteration is going to be n minus k minus c. So n minus k minus 1 is greater than 0. This is our base condition here, right? When I is greater than 0. So in last iteration the value of I becomes n minus k minus 1 c. So after solving this we get k equal to less than n plus 1. So we are not interested in lower order term, so we cross out the 1, we cancel out the 1 and it becomes k less than n. So finally we get the order of growth of this for loop is going to be theta of n. So far we have seen 3 examples. One is the constant order of growth, one has linear order of growth, and third also has linear order of growth. So let's see some different example. So now let's see some other examples having different order of growth. So this is our next example. So in this example what we are doing, we are running a loop from I equal to 0 till I less than n, and instead of adding and subtracting, now we are multiplying c with the I in each iteration. And inside this loop we are doing some constant operation. Same as previous example, our n is the user input. It could be anything, it could be any small value, it could be any larger value, and c is going to be some constant value. Now if I ask you that what is the order of growth of this function, then now it is difficult to say that what is the order of this function, because instead of adding and subtracting, we are simply multiplying the constant in each iteration. So no problem. To solve this issue, let's dry run this example with some arbitrary value. So let's say if n equal to 33 and c equal to 2, let's dry run this for loop. In first iteration our I becomes 1, then we multiply our I by c in each iteration, so it becomes 2, then it becomes 4, 8, 16, 30, and at last it becomes 64. So at this point our loop is going to stop. So how many times this loop runs? 1, 2, 3, 4, 5, 6. So it runs 6 times. So we are still figuring out the relation that how many times this loop is going to run. It's never going to be n by 2. So let's see with other values. So let's say if n equal to 81 and c equal to 3, this loop is going to be run. This loop is going to run 1, 2, 3, 4 times. It starts from 1 and then it becomes 3, then it becomes 9, it becomes 27, and when it becomes 81 our loop stops. We meet our base condition and our loop stops here. So how many times this loop is working? 1, 2, 3, 4. Again we are unable to find any relation between n and c. So let's see this with, so if I ask you how many times the loop runs, so again we are confused and we do not have any way to figure out how many times this loop runs, because we are not able to find any relationship between n and c. So mathematics is our friend, so let's take the help of mathematics to solve this issue. So as you can see that we are running a loop from 1 to n, and each time we are multiplying I with c. So we can write like this, that in first iteration it becomes 1 into c to the power 0. C to the power 0 is nothing but 1, so it ultimately becomes 1, and we are starting our loop with 1. Next time we are adding c to it. Next time we are multiplying c to it, so it becomes 1 into c to the power 1. C to the power 1 is also c, so it becomes 1 into c, that's equal to c. Then next time we are multiplying c to the power c to the power c, so it becomes 1 into c to the power 2, and so on and so forth. At the last iteration, it becomes 1 into c to the power k minus 1. And this last term is going to be less than n. And this is our base condition. You can see here, this is our base condition. Our I is going to be less than n. So if we take a logarithm both the side, it becomes k minus 1 less than log base c of n. Okay, and we move minus 1 to this side, it becomes k less than log base c of n plus 1. So again, we are not interested in lower order term, so we cancel out 1 and c, and by cancelling out 1 and c, we get, and after cancelling out 1 and c, we get log n. So the overall order of growth of this function is going to be theta of log n. So far so clear. Let's move on to our next example. So this example is same as previous example, but the only difference is, so we are starting our loop with n and we are running till I greater than 1, and we are dividing c in each iteration, and inside this loop we are doing constant operation. As previous example, our n is going to be a user input. It could be anything. It could be a smaller or larger number. It could be a smaller or larger number, and our c is going to be constant, some business constant. So what is the order of growth of this for loop? So let's dry run this for loop with some arbitrary value. So let's say if n equal to 33 and c equal to 2, this loop starts with I equal to 33, then it divides I by c, it becomes 16, then it becomes 8, then it becomes 4, then it becomes 2, and it becomes 1. When I becomes 1, our loop stops. So how many times this loop is going to run? 1, 2, 3, 4, 5. So we cannot able to build or find a relationship between n and c. So let's see with some other values. So when n becomes 81 and c becomes 3, this loop is going to be run 4 times. First, when I equal to 81, then we divide 81 by 3, becomes 27, 9, 3 and 1. So when I becomes 1, our loop stops. So this loop is going to work. So this loop is going to run 4 times. Again, we are not able to find any relationship between the n and c. So let's call our best friend mathematics, and let's take the help of mathematics to solve this relation. So we are starting our loop by n. So we can write it in a form of n divided by c to the power 0. c to the power 0 is going to be 1, so it becomes n. And in second iteration, we are dividing n by c to the power 1, right? C, I by c. So it becomes n to the power c to the power 1. In third iteration, we divide n by c to the power c. Okay, so it becomes c to the power. So it becomes n divided by c square, and so on and so forth. So our last term is going to be n divided by c to the power k minus 1. So as we are running loop from k 0, as we are running loop k times, so it becomes 0 to k minus 1. So 0 to k minus 1 is going to be k times. So this is our best. So n divided by c k plus, so n divided by c k minus 1 greater than 1 is our base condition, right? You can see here. So let's take a log of both the side, then it becomes log base cn greater than k minus 1. If we move 1 here, then it becomes k less than log base cn plus 1. And after cancelling out the lower order term, our k becomes log n. So the order of growth of this for loop is going to be theta log n. So we have seen 2 more examples. In one example, we are multiplying c with I in each iteration, and in previous example, we are just dividing the c in each iteration. Okay, so let's move on to next example, and this example is going to be more complex than the previous example. Here, instead of multiplying and dividing, we are using power function here. And what power function does, it exponentially increases the value of I in each iteration. So let's say this loop starts with the I equal to 2, and we are running this loop till I less than n. So in each iteration, we are increasing the power of I with c, and we are doing some constant operation inside this function. So just Like the previous example, our n is going to be a user input. It could be anything, smaller or larger value. C is going to be some business constant. Now if I ask you what is the order of growth of this function, then what you are going to say? So please pause this video and think about it. Let me give you a hint. The order of growth of this function is going to be even smaller than log n. So think about it. Pause this video, think about it, and come back again. So let's dry run this for loop with some arbitrary value. So let's say if n equal to 33 and c equal to 2, this loop is going to run from I equal to 2. Then the power of 2 to the power 2 is again 2 to the power 2 is going to be 4. Then 4 to the power 2 is going to be 16, and 16 power 2 is going to be 256. When I reaches to 256, this loop is going to stop because 256 is less than 33. So how many times this loop is running? 1, 2, 3 times. So let's see with other values. When n becomes 5, let's say if n is 514 and c become 3, we'll start our loop by 2. 2 to the power 2 is 2 to the power 3 is going to be 8. 8 to the power 3 is going to be 512. And 512 power 3 is going to be 1, 3, 4 to 1. It's a long number. So when our loop I reaches here, our loop stops working. So you can see that the order of growth of this function is going to be very slow. So only in 3 iterations we reach this bigger number. Okay. So if I ask you how many times this loop runs, it is going to be difficult to guess. So let's use mathematical approach to get the order of growth of this for loop. And let's take the help of mathematics and find the order of growth of this for loop. So as we are starting our for loop by 2, so we can write 2 to the power c to the power 0. C to the power is 0 is 1, so 2 to the power is going to be 1. In next iteration we are again increasing a power by c, so it becomes 2 to the power c to the power 1. And in third iteration we are again increasing power by c, so it becomes c2 to the power c to the power c. So c to the power c and c to the power c is going to be c square. So on and so forth. The last term is going to be c to the power k minus 1. And this is our base condition. C to the power 2 to the power c to the power k minus 1 is less than n. If we take a log both the side, it becomes c to the power k minus 1 less than log base 2 of n. Now again we have to take the log. So after taking log, it becomes k minus 1 less than log base c of log base 2 of n. And after cancelling out the lower order term, that is 1, 2 and c, it becomes k to the power, it becomes k less than log n. So overall order of growth of this function is going to be a log n, isn't it? So this is really interesting. So the order of growth of this for loop is really slow. Let me show you some common order of growths. So these are some common order of growth, and it is arranged in increasing order. So it means the order of growth is constant is less than log n, and the order of growth of log n is less than log n, and the order of growth of log n is less than n. So in this video we have seen all the examples. We have seen example with the constant order of growth, we have seen example with the linear order of growth, we have seen examples with log n order of growth, and we have seen example also with the log n order of growth. So I hope after watching this video you get the clear understanding of how to find the order of growth of a common loops, because loops are the most common used components in programming. So it is crucial to know about loops and the order of growth of different types of loop. This is it for this video. Thanks for watching. See you in the next video.